Hi everybody, in this next video we're going to continue with whole numbers, but actually talk about exponents and the order of operations. So now that we've actually gone through adding, subtracting, multiplying, and dividing, we can start combining them all together into the same example. So we're going to talk about exponents today. And the order of operations. Okay. So first of all, let's start with exponents. Okay, so an exponent is used as a shorthand to write repeated multiplication. So we've already seen that multiplication is repeated addition, division is repeated subtraction, but exponents are repeated multiplication. So here are some, again, definitions to kind of think of here. And I want to give you an example. So 3 to the 5th is an exponential expression. In the exponential expression, the 5 here is your exponent. It is the number of times to multiply. And then your 3 here is called your base. And it is what is being multiplied. So 3 to the 5th is the same thing as taking the number of 3 and multiplying it out 5 times. Okay, so the base is what's being multiplied, and the 5 in this case, the exponent is how many times you write it out. So we're multiplying that 3 out 5 times here. Okay. There we go. All right, some other things here. There are certain exponents that we give special names to. Okay. Also, sometimes we call exponents powers. I will make that note as well here. So I'm going to use 3 here again. Let's say, actually, let's do something different. Let's use 7. So 7 to the 2nd power is also called square power, like we'll say squared. And if you have the 3rd power, I should just say power, then we say it is cubed. So if you hear the word squared, it means the 2nd power. If you hear the word cubed, it means the 3rd power. And let's just do some examples. So evaluate the expression. So maybe I have 7 squared. Maybe I have 2 cubed. Maybe I have 1 to the 4th power. Now, evaluate means to find the value of. Okay, so evaluate, the word value is right there. So 7 squared means to take that 7 and multiply it out twice. 7 times 7 is 49. 2 cubed means to take that 2 and write it out 3 times. 2 times 2 is 4, times 2 is 8. Be careful, everybody wants to say 2 cubed is 6. This is not 2 times 3. This is not 7 times 2. This means number 2 3 times. So 2 times 2 times 2 is 8. Number 1 4 times. 1 times 1 times 1 times 1. Well, 1 times 1 is 1, times 1 is 1, times 1 is still 1. How about 0? What if I said 0 squared? It would be 0 times 0, which is also 0. Let's do one more example here. Right? Using exponential notation. So here we're going to go the opposite way. So what if I had 4 times 4 times 4? Or maybe I have 5 times 5. Or maybe I have 6 times 6 times 6 times 6 times 6 times 6 times 6. So we can also write it using exponential notation and go backwards. So here I have 3 4s. My base is 4. My exponent is 3. Here my base is 5. I have 2 5s, so my exponent is 2. So remember, your exponent or your power is the number of times the base is multiplied. Okay. Here I have 1, 2, 3, 4, 5, 6, 7 sixes, so 6 to the 7th power. Okay. So again, it's just sort of a lazy way to write multiplication. Now, the next thing we're going to talk about is the order of operations. And we've actually been doing this already a little bit. That's something that I think everybody knows, but we're going to review it here as well. It's very helpful to review, particularly for more complicated problems. So what this does is this gives the order in which to simplify expressions that have more than one operation. So by operation, I mean like addition, subtraction, multiplication, and division. So how do you simplify a problem if it has both adding and multiplying, or both subtracting and dividing, or maybe all 4? We have to have a systematic way to do that so that we can all agree on the same process or the same answer, right? We don't want to have 2 different answers if someone does it one way and someone else does it a different way. So we have an agreed upon step-by-step method to do that. And the first thing you're going to do is you always do perform all operations within grouping symbols. Okay. Now your grouping symbols could be your parentheses, they could be brackets as well. We're going to see later on things like absolute values and roots or radicals, so those all are included there too. As a little note here, if you have a complex fraction, the fraction bar is a grouping symbol. So you simplify by top and bottom separately first. Okay. After you do your grouping symbols, you do the exponents next. Third, you simplify your multiplication and your division. And the key thing here is that you have to work left to right. So you do whatever comes first. Multiplying does not come before division. It's whatever comes first in the problem. They're equals. And then the last thing you're going to do is you're going to do your addition and subtraction. And again, you do have to work left to right here. And this always trips students up because they just kind of get used to doing all the adding first and then the subtracting second. And that's not how it works. These are equal. So you have to do them in order from left to right. Other ways you may have heard this. So some students remember this as PEMDAS, P for parentheses, E for exponents, M and D for division, A and S for adding and subtracting. So if you hear the phrase PEMDAS, or please excuse my dear Aunt Sally, again, these are just ways to remember the different orders. So P stands for parentheses, E stands for exponents, M and D stand for multiplication and division, A and S stand for adding and subtracting. So that's a helpful way to remember them, but you do want to remember that multiplication and division could go the other way. They work together. And the same thing with adding and subtracting. So you want to make sure you don't mix that up. So let's do a few examples with order of operations. And we'll start with some easier ones. So let's say I have 5 plus 2 times 10. No parentheses here, no grouping symbols at all, no exponents at all, but I do see I have addition and multiplication. So if you go back to your steps, and if you may need to put those on an index card for right now, just to keep them with you, go through those steps. Check for grouping first, check for exponents next, and then you're looking for multiplication or division. So I do have some multiplication here, so I'm going to do that first. And 2 times 10 is 20. So this becomes 5 plus 20. And then I get the answer of 25. Let's see, how about 4 times 5 squared? No grouping symbols yet. I do have exponents though, so I have to do the exponent first here. I do 5 squared, which means 5 times 5, which is 25. Becomes 4 times 25, which is 100. Now, being careful, if I wrote the last problem like this, that would change my answer. So now I have grouping symbols, I have parentheses. So I have to do inside parentheses first. 4 times 5 is 20. This becomes 20 squared. Now, 20 squared means 20 times 20. So you can do out the multiplication there, or if you remember the shortcuts with zeros, when you're multiplying with zeros, you can just do the digits. 2 times 2 is 4, and then I have 2 zeros, so I just tack on the 2 zeros. So that's an easy way to multiply with zeros. All right, let's do another example. Maybe I have something like 4 times 6 minus 1 times 2. Now, I do see parentheses here, but they're not grouping symbols because my parentheses here represent multiplication. True grouping symbols have something you can do inside them. So you want to be careful. When we're talking about grouping symbols, we mean inside the grouping symbols. So here, there's nothing inside the parentheses. They just mean multiplication. So I have multiplication, I have subtraction. I have to multiply first. So 4 times 6 is 24. 1 times 2 is 2. Now I can do my subtraction. 24 minus 2 is 22. All right, let's kick it up a little bit. All right, so here I have a few different operations. I see subtraction, division, multiplication, and an exponent. I don't see any grouping symbols, so that's where I would start. After that, I would do my exponent next. So what I'm going to do is just be really careful and rewrite everything in the exact order. Don't change the order of things. You have to keep it nice and lined up. Now, 6 squared means 6 times 6. That's going to be 36. Next, I would go on to multiplication and division. Now, be careful here. Multiplication and division, don't forget, you work from left to right. So everybody wants to do the 4 times 2 first, but we don't do that. We do the division first because it comes first in the problem. So 8 divided by 4 is 2. I bring down everything else. And then 2 times 2 is 4. Now, again, I have subtraction and addition, but just like before, adding and subtracting, you have to work left to right. So I do the subtraction first, I get 0, and then 0 plus 36 is finally just 36. All right, I'm going to do just a couple more examples with you, because these are good to practice. All right, so here I have two sets of grouping symbols. I have parentheses and I have brackets. When you have two sets of grouping symbols and one is inside the other, then you have to just do inner to outer. So I'm going to start with the innermost one first. 4 minus 2 is 2. Notice that I'm just rewriting everything else exactly the same. I'm just doing one little step at a time. Now I have another set of grouping symbols, so I'm going to work inside here first. And when I'm on the inside, I'm still following the order of operations, which means I'm going to do the cube first. So here I have 2 cubed, which is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. All right, I still have those grouping symbols and I still have something to do, so I'm going to keep going. 8 plus 5 is going to be 13. Now I still have the brackets, but there's nothing left to do on the inside, so that part is done. I'm going to move on now. And I do see I have exponents here. Let me just change colors for a second. So I do have this exponent piece here. So I'm going to do that next. So 13 squared means 13 times 13. 3 times 3 is 9. 3 times 1 is 3. Put my placeholder. 1 times 3 and 1 times 1. So I get 169. So this becomes 2, 160. Now, when there is nothing in between a number and a parenthesis or a bracket, it is multiplication. So I have multiplication and addition, and multiplication comes next. So I'm going to do this off to the side. 169 times 2. So I get 18 carry the 1. Then I have 12 plus 1 is 13. 2 plus 1 is 3. This becomes 338. Finally, 338 plus 6. I have 344. Okay, so I just take my time with these, go one little step at a time, really don't try to rush. And let's do one that has kind of like a fraction in it. So 7 minus 2 times 3. So when you have a more complicated fraction like this, you want to do the numerator and denominator separately first. And kind of say this big division bar for the end that actually represents a grouping symbol. So it's like you do the numerator, you do the denominator, and then we'll come back to it later. And within the numerator and denominator, you are using PEMDAS. So I'm just going to do the numerator first here. So in the numerator, I see subtraction, multiplication, and an exponent. The exponent comes first. So I have 7 minus 2 times 3. And then 3 squared means 3 times 3, which is 9. Then I see adding, subtracting, and multiplying. So multiplying comes next, right? I'm going back to the order of operations steps. If you don't know them, then take out your notes and just keep these out with you the whole time. Every time you're doing an example, go right down the line. After exponents comes multiplication and division. Right, 2 times 3 is 6. Again, I'm just going to keep going with the numerator here. And now I have adding and subtracting left, which is the last step, and I go left to right. So I do the 7 minus 6 first, which is 1. And then the 1 plus 9 is 10. In my denominator now, I do have grouping symbols here, so I'm going to have to do the 4 minus 3 first, which is 1. Now, I still have grouping symbols, but there's nothing left to do on the inside, so this is just representing multiplication now. 5 times 1 is 5. Finally, I have 10 divided by 5. That's still a division bar, and my final answer here is 2. Okay. So again, for those, just remember to take your time. One last thing, just a little like silly kind of example here. I know before we talked about area, right? And the area is the length times the width for a rectangle, but we also saw when we have a square, the length and the width is the same, so you just have the sides, right? So instead of doing side times side now, we can do this as side squared. So let's say I had a square that had a side of 3 inches all around. Then my area here would be 3 squared, which is 9. And then don't forget you are squaring your units as well. So 9 inches squared, or you can write 9 square inches, or 9 SQIN. So just a little application here. We kind of talked about it a little bit a few videos ago, but we can finally bring in an exponent now and be a little bit more comfortable with it.